Hey there, in this video I'll be talking about factorization of quadratic expressions. Normally students struggle with this topic, but once you understand the fundamentals, it's an easy topic. You will enjoy doing it after this video is over. Let's have a look. Before we go into the details, let's first try to understand what do we mean by a quadratic expression or a quadratic polynomial. So any expression in algebra that can be written in the form ax squared plus bx plus c is a quadratic polynomial or expression. So the condition is the highest power of x should be 2. A, B, C are integers here and x is a variable. In factorization, we express the quadratic polynomial as factors. So we write ax squared plus bx plus c equal to the product of two linear polynomials, which is x plus something times x plus something. So this is what we'll be doing in this video. Have a look at the first example where we need to factorize 3x squared minus 108. You can see here 3 is the common factor for both the terms. So we take 3 common. In the bracket we are left with x squared minus 36. We rewrite this expression as 3 times x squared minus 6 squared. Now we need to make use of this formula a squared minus b squared equal to a minus b times a plus b. So we can express it as 3 times x minus 6 times x plus 6 using the formula. So 3, x minus 6 and x plus 6 are the factors of the given expression. In example 2, let's now factorize 5x squared minus 245. So have a look at the terms here. You can see 5 is common to both the terms. So we can take out 5 common. In the bracket, we are left with x squared minus 49. So that gives you 5 times x squared minus 7 squared. Next, we use this formula a squared minus b squared equal to a minus b times a plus b. So we can write 5 times x minus 7 times x plus 7. So 5, x minus 7 and x plus 7 are the factors of the given expression. In our next example, we need to factorize x squared minus 5x plus 6. Now, in this polynomial, there is no number common to all the terms. So we need to compare it with the general form of the polynomial, which is ax squared plus bx plus c. And we realize a is equal to 1, b is minus 5 and c is 6. Next step is to multiply a and c, which is 6, and b is minus 5. Now have a look at these two numbers, 6 and minus 5. Next step is to think of two integers whose product is 6 and sum is minus 5. Have a look at the factor pairs here. We are considering different pairs, but only one pair is giving us the required results. The integers minus 2 and minus 3 are giving us the required results as their product is 6 and the sum is minus 5. So we can write the expression as product of x minus 2 times x minus 3. So x minus 2 and x minus 3 are the factors of the given expression. Some students prefer to write in the tabular form. You can also do it this way. In example 4, we need to factorize x squared plus 3x minus 10. So here again we follow the same procedure. We compare our polynomial with the general form of the polynomial, which is ax squared plus bx plus c, and we realize a is 1, b is 3 and c is minus 10 when we compare. So next step is to find the product of a and c and write the value of b. So a and c multiplied gives us minus 10 and b is 3 here. So next step would be to think of two integers whose product is minus 10 and sum is 3. Consider the factor pairs here. We are taking various possibilities. Out of this, only one pair satisfies the conditions. Minus 2 and 5, these are the two integers whose product is minus 10 and the sum is plus 3. So we can write x squared plus 3x minus 10 equal to x minus 2 times x plus 5. So x minus 2 and x plus 5 are the factors of the given expression. Some students prefer to represent in the tabular form. You can also do like this, where it is exactly showing the same information. So you can use either of the methods. In our next example, we need to factorize x squared minus 5x minus 14. Again, we compare it to the polynomial ax squared plus bx plus c, and we realize a is equal to 1, b is minus 5 and c is minus 14. Again, we find the product of a and c, which is minus 14, and b is minus 5 here. So next thing would be to think of two integers whose product is minus 14 and sum is minus 5. Have a look at the factor pairs here. So we are looking for two integers whose product is minus 14 and sum is minus 5. So it's 2 and minus 7. You can see in the table as well. When we draw the table, we find two integers, 2 and minus 7, giving us the desired results. So here we write 2 times minus 7 equal to minus 14 and 2 plus minus 7 equal to minus 5. So we can write the given expression as equal to x plus 2 times x minus 7. So these are the two factors for the expression x squared minus 5x minus 14. In our next example, we need to factorize 3x squared plus 7x minus 6. We compare it to the general form of the polynomial, which is when we compare, we get a equal to 3, b equal to 7 and c equal to minus 6. Next step is to find the product of a and c and write the value of b. So a times c is minus 18 here and b is 7. Next step would be to think of two integers whose product is minus 18 and sum is 7. Have a look at these factor pairs. We are considering different possibilities. One pair is giving us the required results, and that these two integers minus 2 and 9 are giving us the desired results. The product of these two integers is minus 18 and the sum is 7. So now we can replace 7x by 9x minus 2x. So next step would be to write it as 3x squared plus 9x minus 2x minus 6. We rewrite the expression, and from the first two terms we can take out 3x common. In the bracket we are left with x plus 3, and from the last two terms we can take minus 2 common. We are left with x plus 3 again. Now if you have a look at this expression, we can take x plus 3 common from both the terms, and in the bracket we are left with 3x minus 2. So our factors are x plus 3 and 3x minus 2. So here you can write x plus 3 and 3x minus 2 are the factors of the expression 3x squared plus 7x minus 6. Let's now review the key points. First point is, if there is a factor common to all the terms in the expression, we just factor it out. Next point is, use regrouping or algebraic identities to factorize. That really helps. And number 3 is, write the expression as a product of the factors. I hope by now the method of factorizing the polynomials is clear to you. This is slightly challenging, but I'm sure if you look at the expressions closely and you clarify your fundamentals, you'll be able to master this and you'll be able to gain confidence. So good luck. If there's any question you need to check, you can write in the comments. Thank you. Have a good day.